again, I'm going to be testing the earth rod. This time I'm going to use the method that doesn't require any mains power. It's going to be using either 3 connections or 2 connections. And we've seen the test leads for this in the previous video. It's those very long ones with the green, yellow and red wires. Now, if this was real installation, the first thing we'd have to do is to disconnect the power and lock that off, and then remove the earth connection from the earth rod. And that would obviously ensure that we're only measuring the electrode in the ground and not the main bonding and anything else that's in there. And in this particular case, though, of course, I'm not doing that because this is just a demonstration. The electrode we've got on the ground here isn't actually connected, so that's not going to be done here, but in a real installation, you would need to do that. And you would need to disconnect the power first, because, of course, if you're going to disconnect the earth, that would leave it in a dangerous condition. So let's have a quick look at the rod in the ground. We've seen that last time. And then the test leads that we are going to be using. So here's the leads we're going to be using. We've got 3 here, green, red and yellow. Now the green one is what connects to the electrode we're actually going to be testing. This is relatively short. I was going to be placing the test meter near to that. The red one is what goes furthest away, hence it's the longest one there. That's going to be going way down the end of the garden. And then the yellow one is what goes between those two. And we're going to start out with that approximately halfway between the two. Then we're going to do some additional tests as well by moving this one direction and the other to get a sample of various different readings. And ideally we should be getting those all around the same kind of area. If not, then we'll have to move the red one and try again. So 3 things there, and they go in the order, say red furthest away, yellow nearest and green to the electrode itself. So here's the red one. I've just placed that pretty much as far as we can get at the end of the garden here. This is basically the back of the fence there, so I can't really go much further than that. So the temporary lead just clips on there, and then that spike just presses into the ground. The ground is very wet here. It's been raining for weeks, so no problem with that. And the wire there we have just goes all the way down the garden, as we just saw. And the yellow one I've placed about halfway along, so just placed here in the lawn. So same deal again, just presses in the ground, and then the yellow lead clips on to the side there, and that's roughly halfway between the electrode we're testing and the red one we just placed in up there. And then those leads come down to here, and then in the box here we've got the electrode which we saw in the previous episode. And we'll just have a look inside. There it is, and just connected the green clip onto that one. And again, there's nothing else connected to this, because if there was, we'd actually be testing that as well. So if this did connect back to, say, the installation, we'd end up testing things like the main bonding for either gas, water and everything else as well. So that just goes in there, and then we've got our 3 leads here ready to connect up to the test instrument. So I've got our 3 leads here, red, yellow and green, and these just go in on the back here in the appropriate places, and it says these smaller indications here for the colour. So the green one, which is the electrode we're actually testing, goes into the green where the X is located, so I'll just press inside there. The red one, which is far away, goes into the number marked C, and that's actually the current stake. Essentially what that's doing is putting a current in between this one and this one. And then the yellow one, which is the one we're going to move about shortly, is the potential one, or P there, and that's basically measuring the voltage at that point. Basically it's measuring the sort of voltage gradient across the ground and calculating resistance from that. So that goes into the yellow one there. So let's make sure those are installed properly. Let's place this here. And then the function we're going to select here is the earth testing function, which in this case is the 2 or 3 pole test. This is 3 pole because we've got 3 connected there, and then it's just turning around to the RE position here, and I'll just do a quick check there to see what we've got, and then we're ready to do the test. And just do the test pressing the button, obviously. Okay, so there's our test result there, so 105 ohms. So that's fairly within the range that we had on the test we did previously. Did that loop impedance in the house, it came out in the sort of range of about 100 ohms or so. And I bear in mind that was actually a couple of weeks ago, because these videos not being recorded at the same time. And also what we did before was measuring the actual loop impedance. So that would have included the cabling from the house here and back to the transformer and whatever. So it would have been slightly different. However, the cabling and whatever else is tiny resistance compared to this, because obviously cabling can have resistance in the region of less than 1 ohm. So 105 is what we're getting as a result here. Now that's only one reading. We do need to do several of these, so what we're going to do now is to move the yellow spike which we've got in the lawn. We're actually going to move it towards the red one, and we're going to do the test again, and then we're going to move it back this way towards the electrode we're testing, and again do the test again as well. It's important to do this to get a sample of readings. They should all be around the same kind of value, and obviously if they're not, that would indicate some kind of problem with the temporary electrodes we've put in. So let's just move that, and then we'll have another go. So what I'm just doing here is moving the yellow stake there further away, and basically going closer towards the red one, which is up there at the end of the garden where that trampoline is installed. So now we've got that in position there, we're going to do the same test again and see if we get anything different. And so it should be similar, but of course you never know, so let's have a look. So still on 105 we had previously, so let's just do that test again there. Again, it takes a while to do the business. So. Okay, so this time I've got 106, so again, pretty similar to what we had before. It's less than a 1% change there, so that seems fine. And now what we're going to do is to relocate the yellow spike, but move it closer this way, and again do that test a third time. So actually I'm just moving the spike then from far away and putting it back into the lawn there, but this time quite a bit closer than we had before, so nearer to the actual electrode we're going to be testing. And once again we're just going to test the thing again to see what result we get. So that's the 106 we had from the previous test, so yeah, we'll just start that going again. Okay, so this time we're getting 101, so it's a bit lower there, but again it's well within the range that we would expect. So just a few ohms less there. So in this case we can reasonably assume that the impedance of this electrode is in the region of 105 or so, and that's very consistent with what we had on the previous test as well. We did the loop impedance test. Now those results we had were fairly consistent, so all around the sort of 100 to 110 range, so I can safely say that this particular electrode is in the region of 105. Again, that's consistent with what I had before. Now, if you get results that are massively different, so say we've got 100 on one, then we suddenly got sort of 180 or something, and then we got one that was 74 or something like that, that would indicate that there's a problem with the temporary electrodes that you're actually putting in, and that can happen if the soil is very dry, or if the soil varies a lot between where you're putting them in. So if there was, say, a sort of wet, soggy patch in a flower bed, and then there was a dusty, dry bit of lawn or something. Now, if that does happen, what you can do is to actually apply water to the ground where you're putting the temporary electrodes in, and you can do that for both of those, and that should give you more consistent results. The important thing to do is not to apply water or anything else to the actual electrode you're testing, because of course that will give unrealistic results. So perfectly okay to apply water or whatever where you're putting the two temporary spikes in, but definitely not where the permanent electrode is installed, because obviously if it is dry outside already, you want to be measuring it in that condition so you can see what it's actually going to measure of. So if it's, say, measured very high, you could shove water on it, and yes, it would probably give a lower result. But of course, as soon as you've driven away in the van and whatever, a couple of hours later it's going to dry out and gone back to the far too high reading. But say in this garden it's very wet anyhow, so not a problem with this. Now what we saw there, of course, was doing the